All right, hey everybody. I hope your day's going well. It is time for Cloudy with the Chance of Learning. We have a pretty exciting subject today.
And I hope you all had a safe and happy 4th of July. Today, our topic's going to tie in with Independence Day just a little bit, right?
Yeah, just a little bit. And guys, I'm actually going to turn a light a little bit brighter because we're looking a little dark here.
Surprisingly, because our windows are all wide open.
Yeah, let's go ahead and just take a look here at what we have to talk about today. Just the chemistry of fireworks.
Yes, so looking at the chemistry of fireworks, are we good to go on your end?
Yes, give me 1 second.
All right, so let's look into the chemistry of fireworks. It turns out that there are a bunch of factors of chemistry that cause the colors of fireworks, all goes into the mechanics of making the fireworks burn and also causing those vibrant colors. Now, keep in mind, as far as weather impacting fireworks, it can definitely play a role. You know, we actually had some air pollution issues, especially over different cities across Texas after fireworks shows took place. But what we're going to be getting into is not so much the weather side, but more of the chemistry side. So, like we've been talking about, metal compounds produce an intense color when burned. So you have all sorts of different types of metals, but can you guess any of these metals? Some of them are on the periodic table of elements.
Oh gosh. Magnesium.
Magnesium, yeah. Mg.
Calcium.
Calcium.
Sodium.
Good job.
Barium.
Barium.
Cu.
Copper.
Copper. I was about to say, I'm pretty sure Cu is copper. And strontium. Is it strontium?
I believe so.
That's the one that I would have never guessed.
Yeah.
So
let's pull up the comments too, just to see if anyone has any comments on our Facebook Live.
Okay.
You know, ask us questions when we're talking about the chemistry of fireworks. We're going to dive into a lot about fireworks as well. Yeah. So we have Matthew joining us today. We have Seth. Hey, Seth, glad that you're joining us this Monday.
Yeah.
And Matthew says, I haven't been over for a week, and I'm glad to be back.
Yeah, well, welcome back, Matthew. We're glad to see you again. So, yeah, that's the chemistry, a little bit into the chemistry of fireworks with just some of the compounds in there.
Right. So the reason why I've made these metals different colors is because, you know, don't think too hard about this, but these can play an important role when it comes to the colors of fireworks. But think of purple. Sometimes with purple, you have to mix different colors. So you have deep reds, and then you have blues from copper. So when you combine those two metal compounds can make that vibrant purple color that we sometimes see in the fireworks.
Hold on, did you just turn this into an art class?
Ooh, that's a good one. It's an art class too. Fun fact.
This is not just weather. This is not just history class, 4th of July stuff. But
so everyone also, get your paint brushes out, get your red paint and your blue paint, mix it together. What color do you get? You get purple, right?
Yeah, different stuff. We have Addison on. She's on a different account today. Welcome, Addison, again.
Hey.
Alicia is on. Megan, she says she loves the topic. Good. Matthew says it's a very explosive topic.
I love it. Keep bringing the puns. You got it. So going back into it, you know, fireworks are usually combinations of metals and black powders. Now think of when I was talking about the chemistry behind, you know, when we talk about black powders, we mean gunpowder, right? Because it's easy to burn. It's going to help the combustion of the fuel. So we have some big here, but it's going to be a great lesson. And you know, some metals can generate multiple colors depending on how hot they get.
Oh, I didn't know that.
Yeah, so that's one thing to keep in mind. So they can generate multiple colors depending on how hot they get. Remember that cool little fact there. Nice. Now let's talk about metals that let's talk about first the nucleus and also the electron. So the metals used in salt pellets are made of atoms with electrons floating around them. So you've maybe talked about this in your science and or chemistry class. You know, we have the nucleus, which is the center of the atom, and then we have the electrons, which are negatively charged particles floating around the nucleus.
Okay, yeah, so the nucleus has the protons and neutrons in it, right?
Right, exactly. So the electrons are pretty close to the nucleus, right?
Mm-hmm.
And so keep that in mind of where the electrons are located in an atom. Now, when adding energy, meaning heating up the powder, the gunpowder, so adding energy to the atoms, the electrons will become excited. So this is kind of a hard concept to understand because we can't really make this animated, but think of when heating up the powder, adding the energy to the atoms, the electrons, they get pushed farther away, but essentially they want to stay where they are, right?
Right. It's like a magnetic bond, right? Not magnetic. That's not the word I'm trying to get. What was it in chemistry?
This is a pop quiz question for Andrew, by the way.
I know. I can't remember what it was called, but there's another force that drives them together, right? But
Right.
It's almost like a north and south end of a magnet.
Yeah, exactly. So that's a good thing to think of there. And so think of when adding energy to atoms, aka heating up the powder, the electrons become excited. They get all wound up and then they get pushed farther away. Well, the amount of heat needed to push electrons away varies for each metal. And we just showed you the metal compounds there. So think of that. Think about it just a little bit. And the electrons, they do not like being far from the nucleus. They like, you know, kind of rotating around the nucleus in an atom. So they bounce back to where they were as soon as they can. Okay. And so when they bounce back, in doing so, they release the energy they stored up, particles of light, and we actually see these particles of light. So think of more of wavelengths, right? So when we see the colors in fireworks, this is what we're looking at, the particles of light.
Okay, and they're called photons.
Yes.
Cool.
So that's another. And you may have heard of electrons, atoms, photons, protons. You may have heard that in a chemistry or science class. So some pretty interesting stuff there.
Cool, very neat. Mark, is kind of like boiling water. The molecules become excited and cause the light. Yeah, as it becomes hotter, the molecules do become excited. It can lead to water, just like that.
And you know, Marcus, that's interesting because that's kind of a puzzle piece for tomorrow's topic on how dew forms.
Yeah.
Yeah, so it all happens to go with the water cycle, the matter, you know, from going to a solid, liquid, and gas. We were talking about that. But, you know, this is the chemistry of fireworks, so kind of different when it comes to that. But, yeah, just think of the electrons getting so excited. They bounce away, really far away, but then they want to bounce back. And in doing so, they release this energy. And the energy we see, that's wavelengths of light. So those are typically the colors that we see in fireworks.
Yeah, and you know, we had a question from Matthew. He said, how do they make shapes with fireworks or words? And Matthew, I think that all has to do with how they pack their works into their containers. They're set to blow in different forms and shapes and at different times in order to make those shapes and letters.
Exactly. So let's go back to the features. You know, we talked about the black powder. This is aka the gunpowder. So some people like to call it the black powder, others the gunpowder. But this fireworks burn, and I've showed you the gunpowder composition. About 75% of the gunpowder is potassium nitrate. Then we have 15% gunpowder of charcoal and about 10% being sulfur. So we are really going into the chemistry.
Yeah, here. So it's a lot of different things. Now, are all of these, I guess, flammable?
Yeah, so when they all come together, you know, they're going to make up that gunpowder that will essentially help fireworks burn. Interesting. Yeah.
Megan, all right, so guys, this is another one of those topics that's beyond weather. Megan is really good with these topics.
It's a lot of research.
Yeah, the weather stuff is sometimes easier for us to explain, but Megan's really good about going into the research and trying to find out, you know, how these things work. Because this is beyond weather. A lot of are about weather, but this is straight up chemistry.
And you know, weather impacts fireworks shows too. The wind can sometimes blow the smoke towards spectators and the viewers. Dew point, humidity can make the fireworks appear less vibrant.
Lightning can cause fireworks to go.
We have seen a video in our Arkansas posted that, or I retweeted it, I should say, on Twitter. So check out that crazy video whenever you have a chance.
Yes, a lightning strike caused a thing of fireworks to go off in Arkansas.
Yeah.
A display.
So it was on Friday, July 2nd, that I believe it fireworks, or I'm sorry, July 3rd made the fireworks go off. So that's pretty crazy stuff there. So yeah, heat plays an important role, like lightning, aka heat, right? So yeah, this is the gunpowder composition. So we know about that. The next thing we have is the oxidizer. So typically we have, nitrates, chlorates, those type of things, and this provides oxygen for combustion of fuel. And I didn't include a slide because it kind of goes in depth and I couldn't really find a good image on how to show this, but all of these compounds need to have a bond, and I believe it's called a dextran. So they have a bond, and all these will come together to form, that perfect firework.
And you said oxidizer.
Right.
So I guess they all need an oxygen.
Fire
molecule.
needs oxygen, right?
So you will notice in all of these molecules here, there's an O3, an O3, an O4. Those are oxygen molecules.
And that'll change the name of oxygen too.
True. Yeah. Well, depending on how many oxygen molecules are in something, it could become an oxide or
nitrate,
all sorts of different things.
Yeah, so different things
trying
like
to
that.
go way back.
Yeah.
Back when I learned chemistry.
We had to take a chemistry class for our meteorology degrees at Mississippi State long ago. So it's kind of like pulling old information, kind of getting our brains to jog just a little bit and remember this chemistry, because chemistry is very hard. Algebra goes into chemistry, which I love algebra. I'm kind of a nerd in that way, I guess, a math geek, but I love algebra, and you apply algebra a lot in chem too.
Yeah, I'm more of the physics guy.
Yeah. You can have physics. No, thank you. All right, so let's dive into our first metal compound. Do we have a comment here?
Matthew says, how high can fireworks go? And Matthew, I think it depends all on how much fuel they have to get up. Yeah, high up into the sky. It all depends on how much, not necessarily the gunpowder they put in, but the accelerant they have to lift off.
So do you want to talk about this metal compound here?
Yes. Strontium fireworks. Strontium is used in signaling oil and gas production. So it produces deep reds in fireworks.
So remember, this is kind of, you're getting those deep reds. And remember, you're wanting strontium and copper, kind of fast forwarded here, but copper produces the blues. You mix those two together, and that's what makes the purple.
I think you're saying that because purple is your favorite color.
It isn't, actually. Blue is.
Blue is?
Yeah,
you know this. Used to be your favorite color.
Yeah. Well, it is one of them, I should say. Purple is one of them. So yeah, you have to mix some of these and you'll get different colors. Red, white, and blue fireworks are going to have the same metal compound in those fireworks as well. So kind of a cool thing here. What color is your favorite firework, though?
Orange.
Orange? Okay, so you like the orange fireworks. That would be calcium. So let's dive into copper. This one actually makes fireworks blue and purple. Again, it has the deep reds in order to form the color purple. This is actually one of the oldest metals used by humans. A little fun fact there about copper. And copper is mostly found in electronics and also power generation. I've included a little image there. So it's kind of crazy that this is of a gold metal type look. You've probably seen copper before in real life. Think of a penny, right? The color of a penny, and this forms a blue. Crazy, right?
Yeah, that's wild.
Just crazy chemistry there. And we have Matthew saying thanks, smiley face. So yeah, you can always find these metal compounds on a chemistry periodic table of elements. You can find the number there, some really interesting facts. So outside of this weather classroom, if you want to dive into the chemistry, you can look at where these compounds and elements are on a table of elements. But now we're getting into barium. So now we're looking at the green colors in fireworks. Now, this makes fireworks green, but it's also used in medicine.
Oh, really? So it can be used in all sorts of different things. It is also in oil and gas production.
And I wonder what Ollie has to say
I know.
about that.
Ollie's trying to find out what's going on here. Our little dog is on the floor below us.
He wants pets and attention is what he
Yeah,
has.
that's kind of what I've been trying to work on the entire the chance of learning. I've been trying to keep him happy.
Yeah, exactly. So we're going to get into another one. This is magnesium. Now we're only going to talk about a few metal compounds here, but Mg, that's magnesium, and that's what makes fireworks appear gray and white. But titanium and also zirconium can also make fireworks appear gray and white. And you can find this used in furnace linings or for manufacturing steel and ceramics.
Interesting. So I guess it has to be really hot for it to be able to make those colors.
Exactly. Okay. Yeah. So that's what we're looking at. That's the chemistry in fireworks in a nutshell. Remember that weather can also impact fireworks. The wind can blow the smoke towards spectators. The good news is we didn't have much of a breezy day on July 4th. So we didn't see much of that, but we also had a steady wind. So when you're looking at a really light wind, sometimes it can just keep the smoke in the air and also cause air pollution.
Yeah, and that's something you have to look out for. But something else that you have to always remember when you're shooting on fireworks is if it's really dry, if there's red flag warnings and things like that, because you could start fire. So it's always important to not shoot off fireworks unless parents are around, and they've gotten your permission. I mean, you've gotten their permission to shoot off the fireworks. And also, it's also important to have water nearby to put out any hot spots that may form from the fireworks.
Yeah, so it's always important to stay safe, especially this time of year. We're going to pull up the schedule here. Do we have that by chance?
We do. Give us 1 second, guys. Our audio may cut out real quick. Get right back. Give us 1 second here. I'm pulling it up.
And while he's doing that, again, it all comes hand in hand. You know, we were talking about the water cycle a little bit, the states of matter earlier, and that's going to play a huge role in what we're talking about tomorrow. So we'll think about how dew forms.
Let's see here. Do we still have audio? Sorry, guys. I think we're good. So I'm just going to actually bring it up in this little box here to our right. We're having a little bit of computer issues. One of the things about working from home is that sometimes your computer works a little bit slower than what you'd like it to. So just give us 1 second here, guys. I'm working on pulling up that full so we can see it a little bit better. That way y'all can see the schedule. And here it is. So here is what we have for the next week. We have the chemistry of fireworks was today. How dew forms is tomorrow. That's kind of a fun topic.
Then we have dew versus humidity, right?
Yeah, dew point versus humidity, which Weather Chief Bill Taylor is going to talk about. We talk about rip currents on Thursday. That should be really exciting. We talked about a little bit about rip currents before whenever we talked about currents in general. That was a few weeks ago. Remember, you can go back and watch that on YouTube. We talked all about currents. And then we're taking a field trip to the San Antonio Zoo. Again, we've had a lot of those recently, and it's been a ton of fun.
You've had giraffes, right?
Yeah, that wasn't this last Friday. That was the Friday before, but we had giraffes on. They were fed.
That's awesome.
A giraffe's tongue is purple. Yeah. I just can't get over that. That's crazy.
Yeah.
And we got to learn all about types of giraffes. There's more than one type of giraffe, and it was a lot of fun. If you missed it, I suggest going back and watching it.
Yeah, definitely. So a lot of times we have these field trips now on Friday, so we're super excited to tell you, what's going on out in the community as well.
Yeah, but anyway, guys, we're going to go ahead and get ready to sign off of here. Thank you so much for coming on and joining us. We're going to have more to show, of course, as we make our way throughout the week. So be sure to keep joining us at 1 o'clock every day for Fun Time Friday. But Megan, great job on these graphics.
Thank you. Yeah, I had a lot of fun making them. Remember, there are a lot of metal compounds, and depending on how hot they get, they can have many colors. They can produce multiple colors. So something to keep in mind next time, you're watching fireworks shows outside.
Yeah, think about that chemistry fireworks going off.
Yes.
So y'all have a great one.